plus, then you add cross. Yes, that's incorrect. So then that means I'll have to get 60 because one of the of correct here, then plus the 4 that I'm missing.
Okay, so in the break, before the break, we did the decision tree. The only thing we didn't do is we didn't number our potential nodes, our chance nodes. They like to call them chance nodes, okay? And that's where you're getting your expected value. Thomas, can we just stay here? You guys have class from 10 to 12? Yes, what are you guys doing? I don't know. But this, we're doing this in accounting too, so. Is it? But it's but I'm sure you guys saw that, you know, for the most part, I was very lenient in terms of the market, right? The other challenge when it comes to financial management is if you even as you shared scripts and compared, I'm sure you saw that the structure and fashion in which each of you do things is very different. So we literally are looking for marks to say, what is the logic with each of you? Okay? But that said, don't worry. Those of you who have any concerns, we will address it accordingly, as I have done in the past. And obviously, you've seen that on your portal. It's been amended. So you need not worry. We'll get that sorted. Okay? So just stay with me here because this is very, very important. Does that make sense? Okay. All right. So, as I was saying, this is where also you might have some problems because you can see the numbering. If you get the numbering wrong, it may pose as a bit of a challenge in terms of mirroring what my memo has and what you've done. So for instance, is where let's say if where we have 6, you put 1. Can you see that's going to be a problem because I'll be having 6, you'll be having 1. Okay. So what I'm trying to suggest there is you guys need to go and do more decision tree questions and see how they do their numbering with these nodes. In my mind, initially, I actually would have started with doing 1, moving from the right to the left. Does that make sense? But obviously, that's not how they would have done it. But it's not to say, ultimately, we're still going to get to the same expected values, okay? And ultimately get to the same expected values depending on whichever decision we make. But obviously, in a step-by-step process, along with the method marks, that's where there's going to be a bit of clashes. So if I have anything wrong at the ultimate decisions, then that's where now I might lose out a lot more marks than I actually should have. Does that make sense? Okay. So when you are doing your labeling, make it also very clear. So that in the event I have 1 where you have 6, I can still see that, oh, okay, even though the chance nodes were different, they did get the process and they obviously did calculate the right amounts. Does that make sense? Okay, right. Okay, anyway, so now the next step is obviously to get your payoffs at these respective points. Okay, so I want you guys within your groups to then begin to do that. Okay, so if you can just at least do that for A all the way until I. Okay, A all the way until I. Want to get those payoffs. Okay, so here you can see the structure that you guys should have in terms of those particular, in terms of obviously calculating your payoffs and then the expected value at those payoffs. So this is going back to what you highlighted earlier, Thomas. I've just actually calculated the contribution margin. Okay, so maybe just to go back for the benefit of others. Here, they told us that our selling price was 0.60 cents. All right. Fortunately, in this question, they kept that consistent. Okay. Here you go. There you go. So, and also across the different probabilities, they kept the variable cost consistent. Okay, so for the first probability, obviously then your marginal contribution would be your 0.60 cents minus the 0.25, which would then give you 0.35. Okay, and then the next one would obviously give you 0.30, and then the last one would give you 0.24. Okay, so I just want to do that so that we're all on the same page. So now going back to where were we? Yeah, this is where we were. Going back to, that's where these contribution margins are coming from. First probability, as we calculated, is 0.35. Sorry, first contribution margin, 0.35. Second contribution margin, 0.30. And then finally, 0.24. Okay, and you can see they're consistently doing that. Even if we go beyond, you see they are consistently using those same contribution margins. Okay, but anyway, let's get to calculating the payoffs. Open this up, and then subsequently the expected values. This file? Yeah, I can save it as a PDF. Now I'm just thinking. I'm moving between files. Because remember, there's different tabs that I've been clicking on. But I'll share all of them with you. But when I share them, now I'm curious whether I should share the ones without answers or the ones with full answers.
No, it's all this makes sense fractionally.
Yes.
I'm going to be flipping between like the middle part of it just to make sure that actually makes sense.
Okay, so then I'll share. Yeah, the one with full answers is then just one document, so that makes everybody's life easier. Okay. Are we winning? Are we managing to calculate the payoffs? How do we calculate the payoffs?
720 times the contribution margin.
So 720, where are you getting the 720 from?
Your number of units.
Yes, it's the demand. Okay, so we got 720,000 units for the first potential outcome, right? And then we're saying times our contribution. How much are we expected to receive with this first probability? 0.35, okay? And then? All right, and then minus our cost. So let me just quickly do this. All right, what is our cost? How much are we paying for this machine? The 500 batch one? 25,000. Okay, which then gives us a payoff of 227,000. Okay, but then what now is the expected value from that particular outcome if it is to occur? We now need to times our probability. Remember, and this is where we got confused a bit yesterday, Ash. Okay. So here, we've already calculated the payoff. I'm highlighting that let me highlight that in yellow. Okay. But now I want to show how we're calculating the expected value, which was correctly highlighted. We just say 0.20, which is our probability, and voila, there we go. Okay, so you'll see that this process is actually tedious. That's where it becomes a bit challenging. So fortunately here, I can just copy and paste. Okay, so here, but now what has changed? Here, what has changed is the contribution margin with this particular outcome. Okay, so I'm going to erase this. Okay, and this time I'm getting 216,000. Okay, so this is also going to change, and then therefore this is also going to change. Okay, and then again we take this, copy, and we times it by our probability of 0.20. Are you guys getting the same amount? Is it making sense? Am I moving too fast? Okay, so everybody's happy. Okay, right. Now with C again, same thing. Let me just copy this whole thing, and then we'll make the necessary amendments. So here the contribution is 24. Okay. Okay. It's not far away at all. Not far away at all. So can you see now when it comes to D going to E, sorry, D going to F, I've highlighted it in purple there for you guys. Can you see we're basically calculating the options that are going to lead to 2, isn't these ones here? And there we're saying we have a demand of 1.2 million. Okay, but these calculations are exactly the same. The only difference is now the demand has changed. Contribution is still the same. It's just simply the demand. Okay, so you can really just copy and paste. And once we're done with this second leg, I'll then just discuss the remaining stuff. So this is why I'm quite confident they would not give you a question this long in your exam, because this would take you quite a while. But obviously they can make it so much shorter, but still bring in all the necessary principles, assess all the necessary principles. Right. Okay, there you go. And then the last one. Okay, all right, so there we go. All right. So now, obviously, to calculate 1, what must we do? Remember, one is a weighting of A, B, and C, isn't it? So all we need to do is add the expected value of A, B, and C. All right? So that's exactly how we then calculate 1. Okay? So here, what are our values for A, B, and C? Let me be consistent here. Come, guys.
45,400.
400. And plus?
38,200.
38,200.
88,680.
88,680. Okay. All right. And does that give you a total of 172?
Yeah.
Okay. Right. Okay. Now, once you have that, you have 1, you're going to do the same thing to get 2. But remember, there's a 50% chance that we get the expected value at 1, and there's a 50% chance that we get the expected value at 2, isn't it?
Yeah.
So to get the expected value at 7, what must we do?
Two values times 50%.
The two respective values times 50%, you add them, and then obviously you get the expected value at 7.
The 172, 172,280, and then 3,800. Those both become about 15 brackets when you add them together. Oh, there's nothing.
Exactly, 100%. Okay. So now I'm sure you guys are seeing what I was saying in terms of it's a tedious process, especially the more outcomes they give you. Okay. But you'll actually thoroughly enjoy this once you have gotten it. So just practice and you'll be 100%. Okay. And then you obviously do the same thing to get your 9 and 8. Okay. So can you see now what I was saying? Earlier on, Thomas, you asked me, do we have to do your decision tree? And I said, for obviously the purposes of today's class, I said you have to. Because this just helps you navigate to say, where am I? Because remember, the whole objective is to work your way backwards to your 2 values, to find out the expected value of your 2 decisions, your 2 primary decisions, okay? So, I'm now going to go to the document I'm actually going to share with you. Right, so eventually, once you've done that, okay, because we're now just literally doing the same thing over and over, you then say to yourself, okay, when looking at buying a machine, in other words, when looking at 7, 8, and 9, which of those options give me the highest expected value? That's going to guide us on what? Making what decision? Why do we want to know which one of those potential choices between buying a machine of 500 batch size, 1,000 or 1,500? Why do we want to know which one is going to give us the highest expected value?
To see if you should put the decision or not.
To see which one we should buy. Okay? To see which one we should buy. Because we remember, we're always trying to maximize shareholder wealth, isn't it? So, once you have established that, that's going to tell us which machine we should buy, assuming we are going to buy a machine. Okay? Right. So, if we look here, this is basically what option 10 is us buying a machine. Option 11 is us not buying a machine, leaving things as they are. Okay? So, if we look, 0.7, we're getting 238,040 Rand. Option 8, all right, this is now, I believe, with the 1,000 batch size machine, 249,840. And then obviously option 9 should be the 1.5, which is 245. 240. So obviously we're going with which batch size machine if we are going to buy. Which one? 1000. Okay. All right. But then we have to ask ourselves the question, do we get more by way of buying a machine, or do we get more return by way of doing nothing? How much do we expect to receive annually from doing nothing? 200,000. Okay, so is it better for us to do nothing, or should we go and buy? We want to buy a machine. Okay, because we are going to get 249,000, a whole 49,000 more. Okay, so the company should ultimately hire the 1,000 batch size machine. Ladies and gentlemen, that is your 6.3. Any questions or thoughts? So here, when you see decision tree, just know one thing. You will live and die by the quality of, ultimately, yes, but this right here. If you can lay this out correctly, you're going to get your marks. Okay? Because I know the calculations of expected value theory, you're not going to have problems with that. So as long as you get this right, then you're home and dry. You just need to remember, the thing that students often forget is to minus the cost of my 500 batch size machine, my 1,000 batch size machine, and then obviously my 1,500 batch size. As long as you do that correctly, calculate your payoffs, you should be home and dry. Okay, so this is learning unit 6. We're done. So next time I see you, we will be discussing learning unit 7. Okay, right.
So then how much question 2 was out of for